Hello, I'm Anna Mackay and this video is on the area between two functions. So here's our definition. If we have two functions, f of x and g of x, and they intersect at x equals a and x equals b, and let's have a look at this one here. If f of x is greater than g of x, so that's the one on top or the higher function for between a and b all the time, then the area of the shaded region between their points of intersection is given by this definite integral. So essentially you take the function of f of x and you subtract off g of x, calculate that and integrate and apply all the rules that we've been practicing up to now. And that theorem still applies if the whole intersection region is below the x-axis. The same theorem will apply. So we're interested in the one that's on top or above. So here is f of x. Now a variation on that in this concept is the area between the curve and the x-axis, where part of the area is above and part of the area is below the x-axis. So what happens in this scenario? There's a couple of ways of looking at it. So the first way is that you could think of it as one function or two. So the one function you may see is y equals f of x. The other way of looking at it is that the second function, let's call it g of x, is actually the y-axis. And the equation of that is y equals 0. So in that situation, if you just look at the first part, the function that's on top is f of x and the function at the bottom is g of x. So that matches with what we were talking about before, because you would have the integral between a and b of f of x take away the g of x function, which is 0, so that in that sense will disappear. So that's this part here. Now the second idea then is you would add on this part where the function that's on top is g of x. So we could write g of x, but I'm going to write 0 between b and c this time. Take away the lower function, which would be f of x. Now, as you can see, what's going to happen is you end up with negative f of x. So negative here, which is the same as moving the negative out the front. So we would be taking it away. So that's why we actually need to have a subtract here in the function to create a double negative, because we need to be adding on areas. Because I guess just clarifying that, what you would get here is a negative value for that integral. And although you can have a negative integral, you can't have a negative area. So in the context of this question, we would have to change it to a positive. So whenever you have a section that's below the x-axis, you'll get a negative integral number. So you need to compensate for that and subtract off that area. Or whenever you come across a section that is below the x-axis, you can take the modulus of that value, and that will instantly make that negative value a positive one. So let's put that into practice. So first of all, we're going to do finding the area of the region enclosed by two curves. So more like the first picture that we had. Some little tips here. We need to find algebraically where the two functions meet. So solving simultaneously, solving where y is equal to y. So let's do that here. And we have x squared, take 4x, is equal to 2x. And we're going to solve for x. So rearranging, so all those algebra skills that you learnt in previous years, solving here. So we have x squared takes 6x, and solve for x, so we need to factorize here, common factor of x, and therefore our two values are 0 and 6. So they meet when x is equal to 0 and x is equal to 6. So they're going to be our bounds, upper and lower bounds. But now which one is the upper function? Which one's sitting higher? Well, this is where we need our calculators. So switching over to those, here's one I prepared earlier, and we had x squared take 4x and y equals 2x. So standard view window to start with. Let's see if that's what we need. Yep, that's fine. I'm just going to zoom in. Well, no, we don't need to, because all that we need to work out here is which is the upper function. It's the red one, which will be the linear, the y equals 2x. So that's the one that goes first, and then we subtract off the lower function, so the quadratic. So let's go back and do that. So now we write our integral between those points of intersection, so 0 and 6, and you write the upper one first, so we're going to write 2x, take away with brackets the other function, x squared, take 4x, dx. Now we tidy that up and then integrate. So we have 2x, we're going to have take x squared, and then minus 4x, so that's going to be plus, so we're going to end up with 6x, take x squared dx. And now we integrate as normal, increasing the powers of x, so square brackets, that will be x to the power of 2 on 2, and that will cancel down to 3x squared, take x cubed on 3, our bounds are 6 and 0, and now we substitute in for 6 and then 0. So we have 3 times by 6 squared, take 6 cubed on 3, subtract 3 times by 0 squared times by, well, that's going to become 0. Simplifying that out, you get 36. And the units that we use for this area is literally just units squared. Working that part out on your calculator, we can't do in graph because we need it between the two functions, and it would work it out between 0 and 6 individually, not the region combined. So that's that example there. The second one, here we have the area of the region between the curve, this is y equals x squared, take x, take 2, and the x-axis. We need these regions. So as you can see, we can't just take the integral between -2 and 2 because it crosses the x-axis. So this portion of the integral will be positive and this would be negative. So we need to split the integral. So what was I thinking on that one? We will do this one by hand first, and then I'm going to check something on the calculator. So we have to write an integral that's split. So where shall I write? Here we go. The integral between, first of all, -2 to -1. So that's the first part, -2 to -1. You write out the function, put dx there. Now, the second integral will be between -1 and 2, and this is where you can either put a subtract here and write out the integral, or you can add on the modulus. So if you put a negative, that will counteract the fact that that will give you a negative value. I prefer the modulus, so that's the one I'm going to use. So we put, perhaps I'll even put that in colour. So we write out the integral again here with our lower bound of -1 to 2. We have to write out the function again, dx, and finish off our modulus. So now we have to, it's the same function that we're going to integrate, so you'll be practicing that skill plenty of times. Square brackets, x cubed on 3, take x squared on 2, take 2x between -1 and -2, add on the modulus of same integrated function again. X squared on 2, take 2x, but I should still have the square brackets there between 2 and -1, and then the modulus. Substituting each of these in, so there's sort of 4 numbers you're substituting in. Again, making sure you, whoops, that's, yeah, no, that's correct. Using brackets with all these negative numbers. You would hate to get a question like this wrong when you can do integral calculus, but the thing you can't do is substitute in negative numbers. So continuing on with this, feel free to speed this up while I do this. So -2 squared on 2, take away 2 times by -2, and now we're adding on. I'm going to run out of room, so I'm going to have to squish this in somehow. This is the modulus of subbing in 2 now. 2 cubed on 3, take away 2 squared on 2, take 2 times 2. That's the end of that one. And now this is a subtract, this part of the integral, where I sub in -1. So we've got -1 cubed on 3, take away -1 squared on 2, take away 2 times by -1. Close that bracket, finish off the modulus, can't fit it on my screen, and now work that out. I will just put some of the working out here for you. We end up with 11 on 6 plus the modulus of -9 on 2. So, and the modulus makes that a positive number, so we have 11 on 6 plus 9 on 2 is equal to 19 on 3. Now I just want to show you how to check that on your calculator, because what if you've made an error? You want to make sure that you're getting this right. But there are going to be limitations. This 11 on 6 number is the equivalent of 1.83 recurring, and 9 on 2 is 4.5. So those numbers should be in here. So this should be 1.83 recurring and 4.5 there, but that'll end up being -4.5. So let's check this on our calculators. Right, so in graph mode, if we delete those ones, let's put in, here's the function x squared take x take 2. Let's have a look at our view window. Let's hone in, because we want it between -2 to 2. So I'm going to change my window to say what? -5 to 5. Yep, that'll do. All right, so first of all, we would calculate the integral between -2 to that x-intercept, which was -1. Now there we are, 1.83 recurring, perfect, that's the first one we got. And now we have to do a second one. So g solve the integral, lower bound this time is -1, upper bound was 2, and perfect. There's this -4.5, which you then take as a positive number because you want area, and add them together to get that final answer of 19 on 3. Excellent. So that's the end of this video. If you liked it, give it a thumbs up, subscribe to the channel, and the next video will be the area between two functions but a trig example. Thank you.